Constitution.
Yeah, good morning.
Hands up if you can hear me.
Yes.
Yes.
Excellent. Right. Well, I'm very, very sorry that I can't be with you in person, but President Trump issued a proclamation saying that dangerous people like camp counselors aren't allowed into the country unless they're there already. Now, you've already discovered that camp counselors are dangerous people, and I was one of the dangerous ones, so they wouldn't let me in, but it's a great pleasure at least to be with you electronically. Now, I'm going to talk to you today about a subject which used to be taught in every university throughout the Western world from the early Middle Ages until my generation. And it is no longer taught almost anywhere now, and the world is a very much poorer place for it. And that subject is logic. You will have heard the word logic, you'll have heard that things are either logical or illogical, but you may not previously have learned that logic is an art and a science, and it is the foundation of mathematics and of most forms of science and of learning. And I'm going to begin by telling you a story about what logic is for. When Harold Macmillan, whom you see on the screen here now, he was our Prime Minister in the 1950s, shortly after I was born. When he went 100 years ago to Balliol College, Oxford, and you can see there on the screen the Great Hall, Balliol College, he went there to study classics, as I would go sometime later to study classics at Cambridge. And his tutor said to him on his first day there that nothing you will learn in studying Latin and Greek and the ancient civilizations will be of the slightest possible use to you in afterlife, save only this, that after you have diligently pursued your studies here, you should be able to detect when a man is talking rot. And that, he said, in my view, is the main, if not the sole, purpose of education. So what I am going to indicate to you today is a rough outline of some aspects of the art of logic. It's a 3-year course at university. So I'm going to condense some of the main points of it into this talk today, so that you will get some idea of what logic is and what it's about. So logic's purpose was first and foremost to identify and expose bullshit. There is no faster way of finding out whether somebody is talking bullshit than to apply logic to whatever you hear. And logic is a formal, organized system for discerning the objective truth. And the objective truth is that which is true whether you or I or anyone would like it to be true. It is true in and of itself. So you will gather from that definition that logic has not only a mathematical purpose, but also a moral purpose. Logic is directed towards the truth, and you'll read in your Bible that the God of Abraham, Isaac, and Jacob is described as the God of truth. You will see that the Lord of life describes himself in the New Testament as the way, the truth, and the life. And he promises to send and then sends the Holy Spirit, described in the Bible as the Spirit of truth. So all three persons of the Blessed Trinity are described as having the attribute or trait or property of truth. Now, truth is of incalculable value because there are two schools of thought in academia today. There is the old-fashioned school of thought to which you and I subscribe, which is that there is such a thing as truth, that it matters to try to find it. And there is the school of thought that says that only totalitarian party line is to be followed, and there is no truth outside whatever the Marxists say is true. That is the battleground on which you will have to fight when you go to university. You will be having to deal with those who will try to tell you, even some professors will try to tell you, that there is no such thing as objective truth, that truth, like beauty, is in the eye of the beholder. And what I'm going to try to suggest to your minds today is that there is such a thing as objective truth, that it is of far greater importance than most academics these days will ever understand, and that we must, if the West is to continue to advance, get back to searching for objective truth. So now I'm going to show 11 statements on the screen, and all of these statements are about climate change. They have that in common. But can any of you, on looking at those statements, tell me what else they have in common? I'm going to give you a few minutes just to look at those 11 statements. And then I want you to tell me what is the common factor in all those statements apart from their subject matter. Hands up if you have an idea of what is common. Yes. Stand up and speak out at the front there.
They're all wrong.
They're all wrong, correct, but what particular kind of wrongness do they exhibit? Well, I'll tell you. They are all fallacies. That is, they are conclusions of forms of argument where the premises, that is, the declarative statement on which the conclusion is based, do not validly entail the conclusion. In other words, the 11 conclusions you see here are each following arguments where the facts behind the argument do not validly entail the conclusion. And we'll find out what I mean by entailing a conclusion and what a premise is as we go through. But the point is that all of these statements are logical fallacies. Whether or not the premises behind them are true, whether or not the statements themselves are true, the arguments on which they are based are fallacious. The conclusions are inconsistent with the premises. And so what we're going to do is to look very briefly at each of these 11 fallacies, because they're all different kinds of fallacies. And all 11 of these fallacies were listed originally by the Greek philosopher Socrates, and were eventually written up by Aristotle 2,400 years ago in his book, The Refutation of the Sophists. And the sophist is the ancient Greek word for a bullshitter. So the bullshitters of his day would come up with various forms of argument which Socrates recognized as bogus. Plato then recorded the various dialogues of Socrates with the bullshitters, and then Aristotle, reading Plato's dialogues, realized that these various forms of bogus argument that the bullshitters were using could be categorized into various categories. So he wrote a book about these 11 types of fallacies. What was interesting, when I first began looking at the climate question, which is not the subject of this talk, I'm merely using it for illustrative purposes, I realized that all 11 of these fallacies, which are listed in Aristotle's book of 2,400 years ago, are routinely and regularly thrown at us by the believers in the climate extremist or alarmist or fanatical or communist position, call it what you will. And so what I thought I would do is take each of these in turn and let's have a look at them. And you will learn in this process what these original ancient logical fallacies were. And if logic were still taught in the university, then nobody would dream of trying to put forward arguments as half-baked as the ones we're now going to look at one by one. And here is a statue of Socrates on the left, and the first statement that is wrong is there's a climate change consensus, or to do it in the language, in the tone in which these alarmists talk, there's a consensus. That's the kind of tone. Now this is known to the ancient world and ever since, until my generation, as the head count fallacy. And in the early Middle Ages, the Latin scholars gave Latin names to all these Aristotelian and Socratic fallacies. And this one is known as the argumentum ad populum, the fallacy of mere head count. You can't decide on a complex scientific question like whether climate change is going to be catastrophic or, as I think, beneficial for the planet, unless you do proper scientific investigation. Counting heads among a population distracted by media largely in the hands of totalitarians is not going to give you a rational argument. So the fact that there is suggested to be a consensus does not mean that we should have to follow that consensus. So argument from mere consensus, whenever you hear somebody saying, oh, but there's a consensus and therefore we must act, that is a bogus form of argument. It's one of the most elementary fallacies. And here you can see Barack Obama saying, oh, there's a 97% of scientists agreeing that climate change is real, man-made, and dangerous. In fact, the paper that he was referring to back in 2013 was a paper which had looked at 11,944 scientific papers on climate published in the 21 years 1991 to 2011. And what the authors of that paper themselves concluded in their list, and here is their list, or a part of it, of each of the 11,944 papers, they marked only 64 of those 11,944 papers as saying even so much as that most of the warming over the last, what are we looking at, over the last 21 years was caused by us. So there is no consensus even on that milk and water proposition. And are the slides being changed as I changed them here? Can anyone tell me?
Yes.
Are you now seeing on the screen a small print list of various scientific papers? Can somebody respond?
Yes, yes.
So if I go on to the next slide, you're seeing the next slide, is that right? Yes? You now see a slide with a 2 on the top of the forehead?
Yeah.
Yes, good. I'm just checking that you're seeing the same slides I'm showing. So the next fallacy then is that it's a climate emergency because experts have a consensus. Experts are agreed. But that's simply another of these Aristotelian fallacies. It's the fallacy of appealing to the reputations, vericundia, or the authority of supposed or imagined experts. Now, an expert may or may not genuinely be an expert. Even if he is, he may be finding it profitable to abuse his expertise for the sake of pretending that there's a climate emergency when there isn't, because governments give more grants to emergencies than to states where there isn't an emergency. So there are all manner of reasons why, merely because experts are thought to agree, they, as we've just seen, do they actually agree? Certainly not to 97%, more like 0.3%. And in fact, the question of whether a scientist should listen to the notion of a consensus or defer to that consensus was considered originally by another Greek philosopher called Thales of Miletus, who founded what is known as the scientific method in the West. And the scientific method is a method by which logic is applied to observation, to make deductions, and therefore to advance knowledge of science. And in the East, the founder of the scientific method, some 500 years after Thales of Miletus, was the gentleman you see on this Iraqi 10-dinar banknote here. He was Abu Ali ibn al-Hasan ibn al-Husayn ibn al-Husayn Ibn al-Haytham, and he was a considerable scientist. He was a studier of optics like Newton. He was a studier of physics like Newton. He was really the Eastern Newton, but about 1,000 years before Newton. And he said, he described the scientist as a seeker after truth. And he said that the seeker after truth does not place his faith in any mere consensus, however ancient, however venerable, or however widespread. Instead, he subjects what he has learnt of it to his own hard-won scientific knowledge and to scrutiny, inspection, investigation, checking, and checking again. The road to truth, said Al-Haytham, is a long and hard road, but that is the road that we, seekers after truth, must follow. So logic is the mechanism by which we follow the long and hard road to the truth. And here you find Al-Haytham saying very plainly that just counting heads, even among experts, and saying there's a consensus, therefore that's the truth, that is not only not scientific, it's anti-scientific, because it is two logical fallacies rolled into one: the head count fallacy and the reputation or appeal to authority fallacy. So from now on, whenever anyone tells you that you must believe something because there's a consensus about it, and still more if they say there's a consensus of experts about it, your reply is, that's bullshit. That is exactly what it is. So now we go on to another fallacy. And here you say we can't explain global warming unless we blame it on emissions of man-made CO2. Without man, we can't explain why it's got a little bit warmer over the last 70 years or so. Well, this is a form of the Aristotelian fallacy known as the argument from ignorance. We don't actually know what caused the warming, so we can make up any old excuse we like and blame it, in this case, on ourselves or on capitalism. Well, this is one of the fundamental fallacies. It's the argument from ignorance, the argumentum ad ignorantiam. If you don't know what is causing a given phenomenon, you can't just say, well, we can't explain what does cause it, so we're going to say it's this, and therefore we must be right. That is fallacious form of argument. And now we can test it, because one of the things that logic helps you to do is to test the propositions that are put forward in support of an argument. One of the arguments you hear about CO2 and warming is that the warming we have seen in the last 40 years is unprecedented in human history. Never has there been such a rapid rate of warming before. Well, I've got back to the oldest regional temperature record available in the world. It goes all the way back to 1652. And the period of 40 years, from 1694 until 1733, showed a rate of warming in central England. Actually, that covers most of England, including the southwest, where I'm speaking from today. The warming was at a rate equivalent to 4.3 Celsius degrees per century. Now, you'll notice that this particular record looks very unlike the kind of graphs of global warming that you've seen before, in that it appears to go up and down a lot every year. And it does that because in most parts of the world there is summer and winter. And you can see how very small even a warming equivalent to 4.3 Celsius per century for 40 years is when you compare it to the normal annual fluctuations in temperature, which the climate scientists are very, very careful not to show you. I actually had to get the data and do this plot myself because it was not otherwise available. So then I thought, well, let us look at the last 40 years, up until the end of 2019, which is as far as this record goes so far. And here it is. Now that is 2.7 Celsius per century equivalent. Of course, this is only in central England. This is not in the whole world. In the whole world, it's a lot less. It's only about 0.7. But we've had slightly more warming than much of the rest of the world because of roughly where we are. between the equator and the pole. But you can see that 2.7 Celsius per century is a whole lot less than 4.3 Celsius per century. And 2.7 is the more recent warming. So if anybody ever again tells you, oh, recent warming is unprecedented, just take them back to 1694, Central England, and you show them that this is very much not the case. So now another fallacy. Warming is accelerating, and therefore we are the cause. Well, this too, that is the argument from ignorance. I'm sorry, we go on to number 5 then. What about the cuddly polar bear? Now, the polar bears have become the sort of poster child for global warming concern. But this, as we're going to see in a moment, is the argument from unjustified pity. Now, of course, if the polar bears were standing on the last isolated iceberg as it melted beneath them, and then they were going to drown, that would be appropriate pity. But it's misplaced pity, because the polar bears don't mind how much or how little ice there is in the Arctic. They can swim hundreds of miles at a time without landing anywhere. And if the ice melts, they will go back to the land which they originally evolved about 200,000 years ago. I remember it well. They were brown originally. Then they found it good to move on to the ice as the ice expanded, so they could still get the seals whose blubber they feed on, and they became white to give themselves better camouflage. But they would just go back onto the land if the ice all went. They don't mind if there's less ice. There is a bit less ice in the Arctic, not so much in the Antarctic, about the same down there. But here's the population of polar bears. And I say it's a global population because it is only in the northern, it's only in the Arctic, they don't occur anywhere else. And you'll see that in 1960 it was reckoned there were about 10,000 polar bears in the whole of the world. But in 2018, there's an expert, there's an expert, Susan Crockton, which is at minimum 26,000, at most 58,000, the best estimate of 39,000, 4 times as many bears as there were in 1960, and nearly 8 times as many bears as there were in the mid-1940s when they were still being actively hunted. And it was hunting that was a threat to the bears, not global warming. But you will not have seen this chart or anything like it reported in any mainstream news medium over the last year or two, because they don't want you to see any fact, however compelling, however obviously true, that goes against the party line. But one of the things I'm showing to you here is that if we simply apply logic, and the first step in logic is you check whether the premises on which their argument is based are true. And you see that the premise that the polar bears are declining in population is very much not true. They are increasing in population, and interestingly, their populations are increasing fastest in the areas of the Arctic that are warming fastest, because they, like us, are warm-blooded animals, and they, like us, prefer warmer weather to colder weather. So then they say, oh, when we emit CO2, CO2 causes warming, therefore we are the cause of global warming. Well, that is the fallacy of false cause. It's a particular form of that fallacy, the post hoc ergo propter hoc. We have emitted CO2 causes warming, warming has happened, therefore it's we who cause most or all of that warming. That is not a sound argument, not a valid argument. Because the truth is, there have been much larger variations in temperature in the past when we weren't emitting large amounts of CO2. You've just seen that record from 1694 to 1733 in central England. That wasn't caused by CO2. It was caused by, as Willie soon will no doubt tell you, by an increase in solar activity following what was known as the Little Ice Age, or the Maunder minimum. And so it had nothing to do with CO2. So the idea that CO2 is tuning knob that absolutely controls the climate is based on the fallacy of false causes. And here's another one. We tell models CO2 is to blame, and surprise, surprise, they tell us the same. Well, now that's the circular argument, begging the question argument, where it has a number of names, this fallacy, because it is so commonplace and so wrong. It's also known as affirming the consequent, which means you take the conclusion of the argument and make it one of the premises of the argument, which makes it a round and round in circles argument. And this is known as the argumentum ad petitionem principium in Latin. So that too is fallacy. We tell the models to tell us what they tell us. Well, of course, it's going to give them the answer the model has put in. Then here's another one. Warming causes hurricanes, and so we cause Hurricane Katrina. Now, this is the fallacy of accident, where you're arguing from the general that warming causes hurricane to the particular, so we cause one particular hurricane, inappropriately. Now, sometimes arguing from the general to the particular can be appropriate, but here it's inappropriate. And the reason why it's inappropriate is that it is not warming that causes hurricanes. It is temperature differential between the sea surface and the atmosphere above that causes hurricanes. It is true that you need a minimum temperature of 26 Celsius in order to get a hurricane started. But you also need to have a very clear temperature differential above them. You need to have a lot less temperature above that. Therefore, the more you warm the atmosphere, the smaller the temperature differentials become that drive hurricanes, and therefore what we would actually expect to find with warm weather is that the hurricanes will become fewer and less intense. And therefore, a hurricane such as Katrina, which was a big one and an intense one, the one thing we know didn't cause that is global warming, because global warming would be, as far as the scientific theory goes, less likely to cause hurricanes and less likely to cause intense ones, because it reduces the temperature differential between different levels of the atmosphere and the surface. And sure enough, I thought you would enjoy this. I've got here a list of the average number of hurricanes per year during the presidencies, all the presidents, going back to Ulysses Grant, which is as far back as I could go with this record, and all the way forward to Obama. Of course, the jury isn't in on the Trump administration yet. And what you will see is that if you take the least squares linear regression trend on these numbers, there's been a 40% decline in hurricane activity, measured as the number of hurricanes on average per year reaching the United States. And this is exactly what you would expect to find in a climate which, over that period, has been gently warming. And so you can see how necessary it is, when you start using logic, to check whether the facts behind the conclusion that you're being given are, in fact, correct. And here you see the statement of supposed fact that warming causes hurricanes is simply flat out wrong. It's wrong in theory, and as we've seen, it's wrong in practice. And then here's another one. Arctic ice is melting. That's a particular phenomenon. So man-made warming, which is the general cause, causes it. So here you have the fallacy of converse accident. And this is the argumentum ad dicto secundum quid ad dictum simpliciter. Here we're arguing inappropriately, not from the general to the particular as before, but from the particular to the general. And again, you can sometimes argue from the particular to the general, but you must do it appropriately. Here, it's inappropriate. Yes, the Arctic ice is melting, but it's melted before. So we can't be sure that we are the cause. We can expect that we might be a contributor, but probably not very much. Now here is one of the two nastiest arguments on this list, this and the following one. Skeptics are paid by coal barons, therefore they're wrong, we don't need to listen to them. Now that, first of all, it isn't true. My check from ExxonMobil and the big coal companies hasn't come this month yet again. And this is an attack on the argument, on the man, rather than on his argument. Instead of checking whether what a climate skeptic said is scientifically true, they're just finding a way of smearing the reputation of the scientist or the researcher rather than having to deal with his argument, which they may not be able to deal with. So this is the argumentum ad hominem, the attack on the person and not on that person's argument. But the nastiest argument of the lot, and this is increasingly being used by the Marxists who are pushing the climate agenda, is that if you disagree with us, then we're going to put you in prison. So this is an outrageous attempt by the totalitarian left to silence debate not only on climate, but on many other subjects where they know that they cannot win the argument rationally or scientifically or logically. And so all they do is resort to the argument of force. Toe the line, or we'll put you in prison, or if James Hansen of NASA got his way, we will put you on trial for crimes against humanity and execute you. He actually said that. That is how extreme these Marxists are. So that gives you some idea of why it was that I first realized that what we were being told about climate change, which I had originally believed, actually might not prove to be true. And you may think that I'm overstating things when I say that people are being threatened with prison. But German bureaucrats recently wrote to an old friend of mine, Naomi Zeich, whom you see here behind bars. She is a 19-year-old kind of anti-Greta Thunberg figure. She's the same sort of age as Greta Thunberg, but unlike Greta Thunberg, she's actually read some books and she's realized that climate change scare has been exaggerated. And she put up 3 harmless YouTube videos about this, saying that she no longer believed in climate change. And she was written to by 2 separate German government departments, one of which said she must take down those 3 videos, otherwise they would fine her $1,500 for each video with $200 cost on top, or they would put her in prison for 14 days for each video, or both. That was a threat they made in writing. I couldn't believe it. I asked her to send me the document. It is actually true. That is the threat they made. She said, what do I do? I said, you take them to court. We've arranged funding for her, and she's taking the German administration to court to allow her to continue to exercise her freedom of speech, to spell out what I believe to be the correct side of the climate question in any event. But that is how gradually freedom of speech is being shut down. And you may say, how does this connect with the topic for today, which is logic? Well, the answer is that the left some time ago realized that if people were trained in logic, as you are beginning to be trained, you're beginning to be able to recognize these bogus forms of argument on which the science of logic was eventually built, then people could start thinking for themselves and would no longer be willing to adhere to that or any party line. So the left could no longer manipulate people and make them do what they wanted, because people, if they understood logic, would be able to think for themselves. So in France, for instance, the communist President Mitterrand banned the teaching of logic in all the universities. And that ban endured for 20 years, until the world's most distinguished mathematical logician, who taught me at Cambridge, his name was Adrian Thiele. He eventually went to war from the Université de la Réunion in the Indian Ocean, island in the Indian Ocean, which is a French colony, and he managed to win and defeat the French government, and logic can now be taught once more in the universities of France. But in many universities, it's now off curriculum because what has replaced logic is wokeness, which is simply a newly fashionable word for communism. And so, in order to free yourselves from being indoctrinated by anyone, to keep yourselves capable of thinking for yourselves, the first step is to be able to recognize the logical fallacies that I've just shown you. And to give you again, very briefly, the history of where these fallacies first came from. Socrates would argue in the public square in Athens, the Agora, as it was known. And he there would have debates with the sophists, people who were coming forward with all these totalitarian ideas, and you'd say, no, you've got this wrong, you're using these wrong forms of argument. Plato listened to these discussions and made notes of them and wrote a book called The Dialogues, in which they're all published. And then came Aristotle, who read this book about Socrates. And it was Aristotle, on the right there, who wrote, first of all, the refutation of the sophists. Then he sat down and he thought to himself, what are the reasons why these bogus forms of argument are bogus forms of argument? And from his study of those first dozen fallacies that you've just seen examples of, he worked out rules of logic. roughly how an argument that is a proper argument ought to hang together. And that's what we're going to begin to look at now. And the first thing that you need to know, and you will find this in no textbook of logic, I do urge you to get, there are plenty of simpler textbooks around, there's Lemon on logic, there's Hodges on logic, but the principle of logic, the fundamental principle, is never stated in the text. But here it is. Any statement that is true is consistent with every statement that is true in time or in space, throughout the universe, from when it began until when it will end. Any statement that is true is consistent with every statement that is true, and any statement that is true is inconsistent with every statement that is false. The whole of logic is built upon this principle of the distinction between, not just the distinction between that which is true and that which is not true, but also the universality of truth as it is known. That every statement that is true is consistent with and agrees with every other statement that you could possibly come up with that is true throughout the universe. This is the case. And that is why logic is so powerful. Because truth is self-consistent, the most powerful weapon that a logician has in trying to examine whether an argument is rubbish or not is to see whether that argument is internally self-consistent. So in logic then, what is an argument? An argument is a technical term in logic, and an argument comprises at least one premise, which means a statement put down on the table before you reach the conclusion. And so there must be at least one, there might be several, well, typically two, but there can be more than one, there can sometimes only one. But these premises must validly entail or logically lead to a single conclusion. So an argument consists of the premises and the conclusion. You can see how simple this basic structure is, which it allows for wonderful complexity in mathematics and other areas, but the foundation of logic is basically very simple. So what then is a valid argument? A valid argument, and the word valid has a technical sense in logic, which I will now describe, is an argument whose premises, whether true or false, properly entail the conclusion. Now notice that the premises, the statements from which the conclusion is drawn, may be either true or false. Even if they're false, the argument may be valid, but if they're false and the argument is valid, the conclusion may or may not be true. So a valid argument, I'm going to give you an example of a valid argument in which we have a premise that isn't true. All cows are pink. This animal is a cow, therefore this animal is pink. Now that is a valid argument, but it depends upon the false premise that all cows are pink. Of course, as we shall now show, well, maybe they are all pink. But an invalid argument, here's an example of an invalid argument. All cows are pink, this animal is pink, therefore this animal is a cow. That is not a valid argument. And so there are some subtleties in how you determine whether the premises validly entail the conclusion. Now, if an argument is invalid, if the premises, those preliminary statements, whether true or false, do not validly entail the conclusion, then the conclusion may be true or false. An invalid argument can tell you nothing about the correctness or soundness of the conclusion. And as we've seen, the first premise is false, where we say all cows are pink. And then we can say Buttercup is a cow, therefore Buttercup is pink. Well, of course, if all cows were pink, that would be true, but actually, we've seen that isn't necessarily true. Now, a sound argument is a valid argument whose premises are true. And this is the end and object of logic, as we're trying to find the truth. And so a valid argument whose premises are true means that if that argument validly entails a conclusion, then the conclusion is necessarily true as well. And this is how in science and in mathematics and in all rational discourse, the objective truth is reached. It's reached by a process of finding and presenting sound arguments. Arguments are logically valid, so that the premises are consistent with the conclusion, but in which the premises are true, and therefore the conclusion must be true. Because remember that the universality of truth, every statement that is true, is consistent with every other statement that is true. So if you have statements that are true, and they validly entail the conclusion must be true. Now, to understand this in just one class is very difficult, but this is the most powerful way of increasing your capacity to think clearly, is to understand these elements of logic. Now, here is a sound argument. Some cows are brown. Buttercup is brown. Therefore, Buttercup may be a cow. Now, when you get maybe instead of is in an argument, it ceases to be, strictly speaking, within the realm of logic, because logic is deterministic. You'll see, in fact, it's a horse and not a cow at all. What we want to look at here is the distinction between determinism, which is what logic deals with. It deals with things that are either true or false, and probability, where we don't quite know whether something's true or false. There is a probability that it may be true or it may be false. And strictly speaking, logic is chiefly concerned with deterministic results, yes, no, true, false, whereas maybe indicates probability. But I'm going to indicate the possibility of applying logic even to probability. How many people are there in the room? Can somebody give me a rough count? I think there are about 50. Is that right?
I think more than that, maybe 70.
Right. What I would like you to do, if there are 70, I would like you to divide yourself into 3 teams of 23. And I would like you each to write your name and date of birth and on a piece of paper and give it to the captain of your team. Okay. And I'm going to leave you to sort that out for yourselves.
Okay, 3 teams. Write your name and your date of birth, right? Okay, these three
leaders to collect, and each team leader must have 23 names. Now, while you're doing that, I'm going to go on with the presentation. And when you're ready, the 3 team leaders can let me know, and we'll do a little experiment. So now I'm going to talk about how logic became
name and date of birth.
Influenced by and influential with mathematics.
I think we call it.
Huh? You want to use one pass around?
In these 3 groups, please select a leader so that you can report the answer.
Okay, so we have a leader here. Here's a leader. Who's the leader over here?
So you can report the
right
answer.
here. Okay. And who's another leader? We need one more. Okay. 3 leaders. Okay. So we got 1, 2, and 3. Everybody needs to be in one of these 3 teams.
Name and date of birth.
And there has to be exactly 23 people in each team.
Ah, no. It looks very bad. I don't think we can get 23 like that.
Let's do 18.
Well, make it 2 teams.
Let's do 18, about 18.
Okay, and
if
now
you have
everybody
18, stop.
participate. But because we don't know how many, we didn't know how many people were in the room to begin with. Okay, so
Let's make it equal number. I think it's about argument of probability, so we want equal sample.
Yeah, we want 23 for this to work.
Okay, 23.
Keep of 23.
Do we have 23? We need 23, 23, 23. So let's
I
try
don't think
23.
we have 23 people.
Fill in some numbers.
She's taking data already.
I think he's looking for 69. The devil's number.
666 is the devil.
All right, get 23 names on. Don't put Lucifer. I want to be quick, guys.
We only have about 60 people here.
60.
30.
Okay, 2 lots of 23 will do.
Two lots of 23. Okay.
2 lots.
Okay.
Okay, do 223. It's okay, we mix up.
No.
No, don't worry. Get 46 names. 46 names, 46 date of birth, separate in 2 groups.
That's right. I'll carry on while you're doing that.
Yes.
So now, logic eventually found that it could be still more rigorous if it expressed itself in mathematical terms. And when the various fallacies were studied, it was found that the fallacies were very often based on 2 particular forms of quantity. One, the existential quantifier, that something either exists or doesn't exist.
Christopher,
And the universal.
pause. I don't think they're listening to you.
All right.
It's very difficult to conduct this experiment. Okay, do we have 46 names? Come on. Yeah, come on, faster. You can put down your name and date of birth, quick. No love letter, come on. We want 23, 223, 2 groups. We have the names.
From the row behind you up front is
Once you reach 23, just stop, no? And then combine some names with this one. So left and right.
I haven't realized this caused such complete chaos.
Yes, it's a chaos. Perhaps we can proceed.
Okay, we'll carry on.
Let's carry on.
Righto. So
Let's go.
everybody face front and let's carry on. So mathematics then began taking over logic, or logic took over mathematics. They're both intimately connected with the quantifiers, the existential quantifier that means there exists such and such a thing, and the universal quantifier which says for all such and such things in a category. And so if we now run very quickly through the various fallacies we've just seen, I'm not going to stop on each one, I'm just going to flash through them, you will see that if we use the existential upside down E and the universal, the upside down A for all quantifiers wherever possible, we can reformulate the fallacies as arguments with premises and conclusions, but using the quantifiers. And you see how easy it is to include the quantifiers in all the arguments. There you are, all are agreed that there exists a climate emergency, and therefore there exists a climate emergency. All experts agree that there exists a climate emergency, therefore there exists a climate emergency. There doesn't exist an explanation of warming without man-made CO2, therefore all global warming is man-made. And you can see how the moment you put these quantifiers in, it's a very good way of exposing exactly where the fallacious bit of the argument is. There exists ever faster warming, there exists man-made warming, therefore all accelerated warming is man-made. No, perhaps some of it is, but not all of it. All polar bears are cuddling. No, they're not, none of them are cuddling. All warming threatens all polar bears. No, it doesn't, their population is growing. Therefore, all man-made warming threatens all polar bears. No, man-made warming is good for polar bears. All humans emit CO2. No, they don't. All CO2 emitted causes global warming. Therefore, all humans cause all global warming. No, we may cause some, but not all. And here again, and if I just run through them all very quickly, you can use these quantifiers. Now, the quantifiers are not normally used with text. They're normally used with other mathematical symbols. You can do calculations to work out whether something is logical or We're not going to get into what is called propositional calculus here. But what I will say is that I once had to use propositional calculus when I was working for the Conservative Party, the equivalent of your Republican Party, many years ago. A colleague of mine in the press office where we worked had put a headline on a speech by a very senior Conservative cabinet minister, and the headline said, "Threat of war in Northern Ireland," because there was terrorism there at the time. And the cabinet minister objected. He was a very gallant man. He was the first British escaper from Colbit's Castle during the Second World War. And he was furious, and he wanted my fellow press officer to be sacked for having put this headline on the speech whose text he had sent to the press officer. So I did propositional calculus on a couple of statements in the speech by the minister and making the headline the conclusion, and I showed that the various statements made by the minister in the speech he had sent us for circulation not only validly but necessarily and soundly entailed the conclusion, and that therefore it was not justifiable to dismiss the press officer concerned because what the minister had said did entail the conclusion that there was a threat of war in Northern Ireland. And that analysis, it was just on one page of calculations, that saved my colleague's job. So logic can have all sorts of unexpected advantages. And here you can see that all of these can have a quantitative element in them. And when you start looking at that quantitative element, that's where you see so many of these arguments are obviously fallacious. And so this leads to a little bit of an investigation of how you can apply logic in mathematics. You don't even have to use symbols of text. You can use diagrams. Can anyone tell me what this diagram proves?
Anyone? What does this prove? Sunshine, go.
Yeah.
No answer.
No answer at all?
If you manipulate it enough, you can eventually get what you want.
No. What this diagram proves is the theorem of Pythagoras.
Pythagoras.
Now, all of you learnt the theorem of Pythagoras at school, but you probably learnt Euclid's proof, which was justly described by a famous philosopher of the early 20th century as a triumph of perversity, because it's such a complicated proof. Here is a really simple proof. You have two square wooden frames. In the left-hand square, you have four identical right-angled triangles, and the square on the hypotenuse of each of those right-angled triangles is common to all four. In the right-hand wooden square, you have exactly the same four congruent, identical, green right-angled triangles, and you have the squares on the other two sides. Take away the four green triangles from each of those two, and you're left with, on the left, the square on the hypotenuse, and on the right, the squares on the other two sides. Now, has anyone ever seen a simpler proof of the theorem of Pythagoras than that? No hands, and quite right. That is, I think, just about the simplest proof that's ever been devised, and it is variously attributed to two Indian Hindu mathematicians, Bhaskara and Aryabhata. And we don't know which of the two, but it's attributed to either of those two in the literature. But there it is, an early example of how you can get a profound logical result, indeed the first, not immediately intuitive proof that you ever came across in school. And here is how simply it can be proved if you find the simplest way of expressing the logic of a situation. Here is my way of doing it, where you have a single, rather oddly shaped wooden frame. And this is known, the previous proof, that's a proof by dissection, as it's called. It's a recognized technique in geometry as well as logic. Here is a proof by inclusion. All the pieces of the puzzle are in one frame this time, and it depends on how you look at it. If you take the red square, and then there are two triangles at the bottom there, one in pale yellow and one in orange, then that is the same area as the two triangles at the top, which are of course congruent with the ones at the bottom, and the two squares, the blue and green square. So again, the square of the hypotenuse is equal to the sum of the squares on the other two sides. So there's a rather nice little simple proof by inclusion. Not as easy to understand as Aryabhata's proof, but it's all done in one frame rather than two. So this just shows that you could use all manner of techniques to reach a logical truth, and sometimes quite a profound one. Using mathematics, you can apply logic in a way that gives very powerful results very, very simply. For instance, you can prove that there are infinitely many prime numbers, the prime number being a number which is exactly divisible by itself and by 1. And here's how you prove it. You prove it by one of the most powerful techniques in logic, which is proof by contradiction. That's the proof I use to save my colleague's job. You assume the contrary of the proposition that is alleged. So here the proposition that is alleged is that there are infinitely many primes. To prove that there are, we assume that there isn't, then we find a contradiction, and that means there must be infinitely many primes. That's how it's done. So here we assume that there is, in fact, a greatest prime number, p, and that means there are not infinitely many primes. We assume that there is, and we call it p. Now then, we multiply together all the whole numbers up to and including p, and that is known as p factorial, p with an exclamation mark after it, and we add 1 to that, and that gives you a number q, which is the sum of p factorial and 1. Now, none of the primes from 2 all the way up to p will exactly divide q. They won't be factors in q, because we've added 1 to a number which is the product of all of them. So therefore, it follows that either q, which of course is bigger than p, a lot bigger than p, is either itself a prime, considerably bigger than p, or q is the product of primes, each of which must be larger than p. And so that tells us that p is not the greatest prime number. Now, supposing we could only imagine that, this is an example now, that p was 5. We think of a bigger prime number than 5. Well, we'll multiply the numbers from 1 till 5 together, you get 120, add 1, 121. That happens to be 11 squared. But 11 is bigger than 5. So if we thought that 5 was the biggest prime number, we've already found out that it isn't. And you can do that infinitely. And so with a simple logical argument, we can prove a very profound result, which is that there is an infinite number of prime numbers. However many you count, you may get fewer and fewer, but they will never stop altogether. There's an infinite number of prime numbers. And this shows the power of logic when applied in combination with mathematics. But let's have a little fun here. Here's an algebraic fallacy. Now we start out by saying that b equals a. We define that. We multiply both sides by a. We get ab equals a squared. Then we subtract b squared from both sides. Then we factorize. Then we divide by a minus b to get b equals a plus b, the third line from the bottom. Then we notice that a equals b at the start, so b is therefore equal to 2b, divide by b, and we have proven by valiant algebraic steps that 1 is equal to 2. What have I done wrong? Anyone?
That slide
It's really-
didn't show up, Christopher, sorry.
Oh.
Yeah, very bad. The algebraic fallacy stuff didn't show up.
Oh,
Just
so if I-
equal sign in between. So you got
that
to move
case-
on to Monty Hall problem, please.
I'll go on to the Monty Hall problem. All right. Okay. So the Monty Hall problem is a very famous problem which comes from an American game show about 40 years ago on television. Now the proposition was this. You're the contestant. Monty Hall is your host. There are 3 closed doors in front of you on the stage. Behind 2 of the 3 doors are goats. Behind 1 of the 3 doors is a Ferrari. And if you choose the right door, you get the Ferrari. So that all 3 doors start off closed. Then Monty Hall says, choose a door, and you pick any of the doors from 1 till 3. And he doesn't open it. What he does instead is to say, I'm going to open one of the other 2 doors in which I, the presenter, know there is a goat. So here he's opened door 2. And you've chosen, let us say, door 1. Then, here's the kicker. He says to you, right, To win the Ferrari, the door you choose must have the car and not a goat behind it. So do you want to stick with your original choice, or do you want to change to the other door? You chose door 1. Before we open the door, do you want to switch to door 3? Now, here's my question to you. Should the contestant stick with the door he originally chose, or should he switch to door 3, or does it not make any difference either way? So hands up all those who think he should stick. Hands up.
Stick. Only 3.
Hands up all those who think he should switch.
Switch. A lot more
A few.
people.
Yes. Hands up all those who think it makes no difference.
Make no difference. Yeah, equal amounts, small amount of people.
Right. Hands up those who didn't vote at all.
Okay, there's none. They say nobody.
All right. Well, the answer is, believe it or not, that it does make a difference and that you should switch.
Yeah, change.
Now, mathematicians, when they first realized this, argued about themselves furiously. They couldn't believe that it made any difference. You know, this was the game. You chose your door. The goat door was opened. Then you were told you could have a choice of switching or not switching. They said, surely it makes no difference. But it does make a difference. And here is another valuable lesson in how to use logic. What you can do is break it down into small pieces. So here, you're asked to choose a door at the top of the screen there. You can see this slide, I hope. You choose a door with a goat behind it. If you stick, you get a goat. If you change, you get a car. But another of the doors has a goat behind it, so that's going to happen twice as often as the other option. And so there, if you switch, you get a car. But if it's the third option, where you chose the door with the car in the first place, then you get a goat if you switch. But that means you're twice as likely to get a car than a goat if and only if you switch. But if you don't switch, you're twice as likely to get a goat rather than a car. So you would switch. And mathematicians argued about this for ages until this diagram showed that you break it down to small pieces and you can see exactly what happens at each point in the game show. So that shows how useful logic can be even in simple situations like this. And I'm going to end now with the shirt-left challenge. Now this challenge is for all of you, and I want you each to agree that you will pledge an amount between $1 and $10 to Camp Constitution. And the way that this is going to work is that I am going to ask you 2 questions with yes or no answers. You're perfectly free to answer either yes or no to both questions, but you must, now that you know that logic is important and your thinking must be consistent, the answer you give to the first and second questions must be consistent with one another. So do you all agree that you will pledge each an amount of $1 or $10 depending on the answer to the question that I'm now going to put to you? You all agree to that?
You all agree? Yes. $1 to $10. Yes, they can.
Very, see, $1 and $10. You decide how much, and you're going to have to pay if this comes out the way I think it will come out. So my first question to all of you, and you can answer this in your minds, my first question to all of you is this. If my second question were, will you give to Hal Shirtliff the amount that you have pledged in your mind to give, would you answer that second question the same way as you answer this first question? So that's the first question. Would you answer it the same way as the second question? My second question is, will you give to Hal Shirtliff the amount between $1 and $10 that you have mentally pledged to give? Those are the 2 questions. If you answer no to the first question, then you must answer logically yes to the second question. If you answer yes to the first question, you must also answer yes to the second question. And therefore, ladies and gentlemen, you all owe Hal Shirtliff between $1 and $10. So my final thought, and that's why never mess with a logician. We can tie you up in knots, and it can cost you. but at least in this case it's in a good form. So I end it with this final thought. The principle of logic is very, very powerful. Everything we do in studying logic is directed towards the truth. And as the late Father Vincent McNabb used to say, truth alone is worthy of our entire devotion. God bless you, go to lunch, and thank you very much.
Thank you.
Let's get to eat.
Thank you, Christopher.
Bless you.